Hello everybody, my name is Edezio Kobasa, but you can call me Eddie. I'm a PhD candidate at the University of São Paulo working with research on method learning, machine learning, and automated machine learning. Today I will talk with you about your paper titled MFE toward reproducible meta feature extraction. Today our plan is the following. We will start talking about the problem we have addressed. Then we will expose to you how we handle it. In sequence, we will describe our tool named PyMFE, which automatically extract more than 11 groups of different meta features. Ultimately, we want to share our follow-ups and final consideration with you. Before we start, I just want to share with you our paper. The paper title is MFE toward reproducible meta feature extraction. It was a collaborative work with all the researchers listed here. Moreover, the paper was published in the Journal of Machine Learning Research and also is open to access there. Okay, so in general, we have observed that method learning experiments are challenging to reproduce, and the reproducibility is a requirement for science today. Moreover, we have observed that many researchers implement method features from scratch, bring much rework, and make long-term research difficult. So there is a lack of tools to support method learning research, to engage the researchers and foster collaboration, and also continual research. And so to address that issues, we developed a method learning tool to extract meta features. The tool follows well-known and uniform frameworks for meta feature extraction. We took care to include the main characterization measures available in the literature. During the development, we considered good software engineering practice, making the tool easy to use and include new meta features. We developed two versions of meta feature package. The first was developed in R, while the other was in Python. So now let's talk about the Python version. We call it PyMFE. The figure here shows how the PyMFE workflow was designed. Firstly, you must send your dataset as a feature matrix X and an optimal target vector Y. I said optional because PyMFE can extract meta feature for supervised and unsupervised tasks. After that, the feature data is split into a categorical feature set and a numerical feature set. It is needed because some meta features are designed to only categorical or to only numerical data. Next, the data is sent to a pre-computation process. This process runs all equal computations and shares them with the functions that will be computed in the next step. For example, computing a simple decision tree classifier can be used to benchmark meta features and also to model based on meta features. Then, pre-computation can share this model and avoid replication of computation. This process saves much computational time and is essential for broad different method learning tasks. Then, the basic functions to generate meta features are applied to the data using the pre-computed information. Finally, the output of the functions is summarized, for example, by mean, variance, and histogram. So after the summarization, we have the meta feature ready to be used. Okay, the PyMFE tool has a comprehensive set of meta feature groups and summarization functions. For example, we have meta features from the most known groups like statistical, model based, and the landmark, and to cutting edge such as cluster based, item set, and complexity measures. We also have many summarization functions like min, median, histogram, and quantiles, which can also deal with known values. It's worth to mention that with PyMFE we can extract meta feature from both supervised and unsupervised tasks. We can quickly compute the meta feature in elapsed set time and also confident intervals. Currently, PyMFE can extract more than 3,090 meta features, considering all summarization and different groups available. Moreover, the documentation has a gallery with several examples of use, making you learn how to use the package through examples. Okay, so let's do the final considerations. For the next months, we are planning to develop meta features computations in parallel using ChildLib, and also new meta features from regression tasks. We aim with PyMFE to foster collaboration among method learning researchers, making an easy way to develop new research through a reproducible framework. Okay, so if you have any question, please do not hesitate to contact me through my email or LinkedIn. Thank you very much for your time.